Hello and welcome. I'm so glad you're here. Let me start with these questions. Have you ever seen a product that works really well and at the same time feels like it wasn't designed with everyone in mind? Or worked on something yourself and then later realized there were users or experiences that were not fully considered? You see, moments like that show up more often than we think. In this session, I will share real world examples of systems that worked as designed but reflected the data and assumptions behind them. My name is Maria Jureco. I'm the founder of Belong Inclusivity, a tech-enabled nonprofit focused on helping organizations design more inclusive and equitable systems through data, research, and innovation. My work centers on human sustainability and participation intelligence, understanding where participation breaks and how those gaps show up in real world outcomes. And a big part of that work sits at the intersection of systems, technology, and the decisions that we encode into what we build. So today, we're going to explore how to catch those biases and patterns early and design better before they scale. So let's get started.
The title of our session is Debug Bias Before It Scales. And what that really means is this. As builders, we're used to debugging when something breaks, but bias does not usually show up like that. It tends to sit quietly in the background, in the data we use, in the assumptions we make, and in the patterns our systems learn to repeat. So instead of waiting for something to surface later, we're going to pause earlier. We're going to take a closer look at what is shaping what we design and how those choices affect who gets included and how systems perform at scale. So by the end of this session, you'll also have a practical tool called the pause framework. This is a framework that you can use on any project, what you're working on here right now and what you go on to create next. So let's walk through it. Here's how we will spend our time together. First, we'll look at why bias in AI actually matters, and I'll provide you a few real examples. Here, we'll introduce a design principle that shifts how you think about who you are designing for. And then from there, I'll walk you through the pause framework. It's a simple 5-step approach that you can use across different types of projects. And after that, you'll get a chance to try it. There's a short challenge where you can pause the video and apply the framework yourself. And then we'll wrap with something that you can carry forward. It's a few practical commitments as a builder. So let's get into it. Here, first thing to understand is this. AI does not start from scratch. It learns from what already exists. So it doesn't just pick up our patterns, it can also amplify them. And when that happens, those patterns don't stay small. They scale across systems, decisions, and people who were never part of the original design. So let me show you what that looks like in practice. Here, take a look at Amazon's hiring tool. Amazon built a machine learning system to help screen resumes. And on the surface, it sounds efficient. But the model was trained on about 10 years of past hiring data. And we all know that that data reflected a tech industry that had been largely male-dominated. So the model picked up on that pattern. It started to associate certain signals with stronger candidates. And in doing so, it ranked or downranked resumes that included words like women's. So for example, if they see a resume that has a women's chess club or women's colleges, they will not consider that. And so eventually, Amazon scrapped the tool. But what it revealed was something important. The system reflected patterns that were already there. Here, another example is at the healthcare industry in the US. There was a widely used algorithm in the US that helped decide which patients should receive additional care. The system used healthcare cost as a proxy for need. And here's the issue. Historically, some groups of patients had less access to care, which meant lower healthcare spending. So the system learned to interpret lower cost as lower need. And as a result, here similar conditions could receive different levels of care. Here, it's how historical patterns can shape outcomes in ways that are not immediately visible. Here, another example comes from facial recognition. Research by Joy Bulamini at MIT showed that some widely used systems had very different error rates across groups. For lighter skinned men, the error rate was under 1%. For darker skinned women, it was significantly higher. A big part of the difference came down to the data used to train those systems, which really did not reflect the same level of diversity. Here, here across all three examples, there's a common pattern. The teams involved are not trying to cause harm, but they move forward without asking a key question. Who is missing from this picture? And that question is actually where our framework begins. And before we get to the framework, I want us to reframe how we think about who we are designing for. There's a concept called design margin principle, and the idea is simple. If you design for the people with the most barriers, you automatically make your product better for everyone else's too. On the screen, you can see a spectrum of accessibility needs: permanent, temporary, and situational needs. And under the permanent spectrum or permanent needs, this is someone who is deaf or blind or uses one hand or someone who has a cognitive disability. Here, studies show that about 15% of the world lives with some form of disability. And if you take it into account in terms of numbers, that's over 1 billion people. And then those who fall under the temporary needs could be someone who has a broken arm, cannot use that arm to type, someone recovering from a concussion and now is very light sensitive. And so here on where we are at, every single person in this room will experience this category at some point in our lives. And lastly, those who fall under the situational needs could be someone in a noisy cafe who cannot hear the audio of what they're watching, someone holding a baby with one hand free. These are the daily users, billion of daily users that we have right now today. And so the point being is, when you build for all three, you end up with something extraordinary. And this is called the curb cut effect. Here, curb cuts were originally built for wheelchair users, but now they are used every day by cyclists, travelers with their luggages, people with strollers, delivery workers, skateboarders. Another example that we can think of curve in terms of curb cut effect is the closed captioning. Here, originally, they were built for deaf users, but now they're being used by millions of people watching videos in a noisy environment or learning in a second language. You see, the features you build for people at the margins end up serving the mainstream, and those are just good examples of curb cut effect. And here, systems thinking matters too, because when you design for the margins, you're not just improving access, you're expanding who gets to participate in the system that you're building. So remember, design for the margins, and then the sector takes care of itself. Here, now that we've looked at what this can lead to, let's talk about what to actually do. And this is where the pause framework comes in. It's a simple 5-step way to catch bias early before they make their way into real world outcomes. And it's an evergreen process. It's not tied to one type of project. You can use it for AI systems, creating apps, policies, programs and services, and data tools. Anything that you're working on here and anything you go on to create next. So let's walk through it step by step. Here is the framework at a glance. Let me walk you through each part. P is probe your data. This is about debugging the technical side, your data and your algorithms. A is audit your assumptions. This is where you look at the cognitive side, your own thinking, and the prompts that you write. U is unpack the impact. This is about supply and demand. the real world context that your technology is entering into. S is structure your practice. This is the process, how your team actually works and builds together. And E is evaluate the outcome and impact. This is where you look at results. Did it work equitably, or who gets to answer that? And there are three things to keep in mind about this framework. First, you can use it at any stage, before you write a single line of code, during a testing, at demo day, any point along the way. Here, it works across different types of technology: AI, mobile apps, hardware, data products, policy tools. Bias shows up regardless of the stack. And third, if what you're working on influences decisions, access, or opportunities for people, this applies to you too. Here, finally, hearing that you can keep coming back to, you can use it across projects over time, and it grows with you. Here, let's start with the first step: probe your data. This is usually where bias shows up first, in the data you use and in the way your algorithms learn from it. So, a simple question to start with is: does my data reflect the world as it is, or does it reflect the world as it was, with all of its inequities already built in? Here, here are three things that I want you to look for here. First, underrepresentation. If a group barely shows up in your training data, the model doesn't really learn how to interpret them. And what it doesn't learn well, what it doesn't see, it tends to go wrong. And that shows up in real world use. Second, you have to look for historical bias. These are the data from the past that carries patterns from the past. So you might remove all obvious attributes like names or gender, but that really doesn't necessarily solve the problem because proxies still exist. So things like zip code, school attended, and even writing style, they can all carry similar signals, just in a less obvious ways. Here, look for counterfactual fairness. Counterfactual fairness. This is one of the most useful questions that you can ask under this thing that you're looking for. If I take the exact same person, same qualifications, same behavior, and I only change one thing, their race, their gender, or their name, would the outcome change? Here, 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 here's then something else is influencing the decision. It means that the system is picking up on signals tied to identity and using them to shape the outcome. That's where bias shows up. Here on the right side of the screen, you'll see a checklist that you can use right away. Questions like: who is in my training data? What process might be hiding protected attributes? Have I tested performance across different groups? If I change one data point, does the output shift unfairly? And can I explain the decision in plain language? If those questions are very hard to answer, that's usually a sign that there's more to look at. And just to ground this in a real example, again, Amazon's resume screening tool from 2018. It is trained on about 10 years of hiring data, which reflected a male dominated industry. And so the model picked up on that pattern. It started to downrank resumes that included word women. Here, actually, again, Amazon did not continue that. They scrapped the tool. Again, it was very clear how bias can enter at the data layer, and then it can carry through into the system. Here, here, here too is audit your assumptions. This is the one that often gets overlooked because it turns the focus back on us. A lot of time, bias doesn't come just from data. It comes from decisions we make along the way. What data we choose, how we frame a prompt, who we involve in testing. All of that shapes what the system learns to value. So here are 4 patterns to watch for. The first is the halo effect. This is when we start to trust AI outputs simply because they sound confident or polished. And the more certain it sounds, the less likely we are to question it. For example, A hiring manager might accept an AI generated score without taking a closer look at the candidate's actual work. That confidence can be persuasive even when it needs a second look. Here again is the endowment effect. So you put time and effort into building something, so it's natural to feel confident about it. But that confidence can make it harder to step back and question your own assumptions. It can show up as skipping checks or moving forward without testing certain edge cases. And then third is leading prompt bias. Here, the system reflects back what's already in the prompt. So garbage in, garbage out, bias in, bias out. If the prompt carries assumptions, the output tends to reinforce them. For example, if you ask an AI to write a job description for a rockstar engineer, pay attention to the language or imagery that comes back. You'll often see patterns that reflect common stereotypes because the model is drawing from what it has learned online. Is availability bias. This is when we design for the users who are easiest to picture. These are the people who think like us, use technology like us, or share similar contexts. And the people who don't fit that picture, they often don't show up in the design, which means that they don't show up in the data either. And over time, that can look like low demand. And when actually it may be a gap in how the system was designed. So, what helps here? Bringing in perspectives that are different from your own early in the process. That's very important. Not just at the end, but at the point where decisions are still being shaped. And just to ground this in a real example, research on GitHub Copilot found that developers often accepted AI generated code suggestions without fully reviewing them. Code looked complete, it looked confident, and that made it easier to trust. And that's the halo effect, a great example of what a halo effect would look like, showing up at a scale in tools many of us are already using. Step three is unpack the impact wherein we debug the supply and demand. And this step is where we zoom out. Up to this point, we've been looking inside the system, the data, the assumptions, the structure. So now we step back and ask, what happens when this actually meets the real world? Because our technology, our model, our product, our policies, they don't exist in isolation. It lands in environments shaped by power dynamics, lived experiences, and history. So we have to look at this from two sides, the supply and demand. Supply is what we're building. On the supply side, we look at the impact of what you're putting out into the world. So, useful questions that we should be asking. What does this automate and what does it replace or remove? Does it concentrate power in fewer hands or distribute it more broadly? Who wasn't part of the design process and how might that show up in the outcomes? And how might this be used in ways that you did not originally intend to? Because these questions matter since impact doesn't come from intention. It comes from how systems behave in real conditions. And then the other side is the demand. Who engages with it? Now, we shift to this side because these are the people interacting with what we have built. Not everyone approaches our system the same way. So typically, I see three groups in this particular section or factor, the demand side: the AI advocates, the skeptics, and the excluded users. The AI advocates, these are your early adapters. So they trust the system, and often the system works well for them because it reflects environments that they're already familiar with. Their experience is valid, but it's not the full picture. The second is the skeptics. These are the users who approach with caution. Their perspective is usually shaped by their lived experiences or previous experiences, where systems did not work as expected or it created harm. And that skepticism is valuable because it often highlights where the system needs more attention. And the third group is the excluded users. These are the people who don't appear in our usage data at all. And that absence is very important because low adoption doesn't always mean there's no need for it. It could mean that the system was never designed in a way that felt accessible, that felt relevant, or safe for those people. So when we design only for the advocates, we reinforce what already works for some. When we design with skeptics and excluded users in mind, we build systems that are more reliable and trustworthy for everyone. In fact, when it comes to impact, there's a widely documented case involving Facebook in Myanmar, where the platform systems, including content moderation, were not designed for a low resource language context. So this allowed harmful content to spread at scale, contributing to the real world violence in that country. The next step is about structuring your practice or debugging the process. This is about the team's habits, not just the technology. So there are two ways to handle bias in a project: the waterfall approach and the iterative bias auditing approach. When we talk about the waterfall approach, it's like we build more, we build even more, and then we launch. And then later on, we discover that bias exists after it already harmed people. And at this stage, fixing it is very expensive, it's reputationally damaging, and sometimes it's quite impossible to fix it. While the other approach is the iterative approach, wherein you pause before you start, you pause at your first prototype, you pause before you demo, you pause before you ship or you deploy. And every pause is a chance to ask, who are we missing? What have we assumed? What does this automate away? You see, this approach is more about bias management. And when you look at bias management, we have to make sure that it's not a checkbox approach at the end of the project. Bias management is a conversation between the technical and this human side of your work from day one. So whether you're writing code, designing a service, or shaping a policy, this has to be part of how we build from the beginning. And for all of you who are participating in this hackathon, I really encourage you to use the pause and debug checklist at every commit, not just at demo day, but every time you push new code, ask yourself, did I introduce a new assumption I haven't tested? And there is this example that you can see on the bottom of the slide, Twitter's image autocropping algorithm. It was found that they prefer lighter skinned faces. They crop out darker skinned people in preview thumbnails. And this wasn't caught in internal testing because the testing team really lacked demographic diversity. It was caught by users on Twitter after shipping and through public backlash. So a mid-process bias audit would have found it, and it would have been helpful for them to be able to eliminate this kind of issue already. But it didn't happen. Now we've reached the fifth and final step, and the one that most teams skip entirely. E is for evaluate. Not evaluation as a report you file after the project is done, but more on the evaluation as an ongoing commitment to finding out whether your technology is actually doing what you intended and for whom. There are three questions that anchor this step. First is, did it perform equitably? Test your output across demographic groups after deployment, not just before. Because real-world performance gaps often only appear at a scale when real users are doing unexpected things. Pre-launch testing is necessary, but it's really not sufficient. So whether it's an AI model, a program, or a policy, ask whether did it actually work for the people it was meant to serve. And who is giving you feedback? That's the second question that you have to keep in mind. If your feedback channels only reach people who already trust and use the product, you are actually living in an echo chamber, because the communities most at risk of harm from the technology that we built are often the least represented in our feedback data. So we have to design feedback loops that actively reach the excluded. So we can do surveys in multiple languages, build community partnerships, and open audits. Third question is, what will you do differently? And this one really matters. Evaluation without action is just documentation. When you find something, and you will, write down what you found, what you changed, and when you will check it again. And that commitment to iteration is what separates accountable builders from the well-intentioned ones. A good example is Adobe Firefly. They published demographic performance data after launch and publicly committed to iterating on its training data. And that's rare because most companies bury or ignore post-deployment findings. While Adobe's transparency, it became a real competitive and reputational asset for them. It's a proof that evaluation done publicly builds trust. So evaluation without iteration is just documentation. Build the feedback loop. Now it's your turn. We're going to work through a scenario together using the same framework. I'm going to ask you to pause the video, spend about 3 to 4 minutes thinking through the questions, and then press play to hear the debrief. Ready? Here we go. And here's the scenario. Your team is building an AI tool that recommends which student applications should receive a scholarship for a tech program. The goal is to help reviewers process a high volume of applications more efficiently. So the model is trained on data from the last 10 years of scholarship recipients. Now, I want you to work through these 5 questions, one for each step of the PAUSE framework. P. Probe. Who tended to receive scholarships over the last 10 years? And does that reflect who is most qualified or who had more access to opportunities? Who tended to audit? What assumptions might the team have about what a strong candidate looks like? Who tend unpack? Who might not apply, not because they don't qualify, but because the opportunity doesn't feel designed for them? Who tend S structure. At what stage would you run a bias audit? And who would you want involved in that process? Who tend E is evaluate. After this tool is in use, how would you assess whether it's working equitably? Who would you include in that evaluation, and what would you adjust if it isn't? Who tend Pause the video and come back in around 3 to 5 minutes. Who tend 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 Let's look at what the scenario brings up when we apply the PAUSE framework. Starting with P, which is probe. First thing I would look at is the data. If this scholarship model is trained on the last 10 years of recipients, we have to ask, who had access to those opportunities in the first place? It may overrepresent students from well-resourced schools, English-first households, or students who had more time and support to build strong extracurricular profiles. Who doesn't mean those students were not deserving. It means the data may already reflect unequal access. So if the model learns from that history, it can carry those same patterns forward. Now let's move to stage 2, phase 2, which is A, or audit. This is about the assumptions of the people designing the system. Maybe the team starts to define a strong applicant as someone who writes in a certain way, went to certain schools, or presents leadership in a familiar format. That may feel objective, but it can quietly favor people who already know how to navigate the system. The next phase, which is U, or unpack, and this is where we zoom out. Some students may never apply, not because they lack talent, but because they may not see themselves in the opportunity, or they may have learned from their past experience that Systems like this were not built with them in mind. So, in this particular aspect, low application numbers are not just data. They may be a signal that access is breaking earlier or dropping off earlier in the pathway. Next is S for the structure. So, this is where timing matters. If you only check for bias right before launch, you're already late. The review should happen much earlier when you're choosing the data, defining success, and deciding who gets to evaluate the model. And of course, the review team definitely matters too. If the same people who design the system are the only ones auditing it, important perspectives will likely be missed. And finally, the last phase is evaluate. Who tend launch, we need to ask what actually happened? Who received the scholarships? Who applied? Who disappeared from the applicant pool? And who gets to help interpret the results? You see, evaluation is not just a final report. It's part of staying accountable to the people affected by the system. So, as you compare this with your own answers, they may not be exactly the same, and that's okay. The goal is not to find one perfect answer. The goal is to build the habit of asking better questions earlier and more often. Who tend? So now the question becomes, what do we actually do with all of this? Because you see, awareness is where this starts. But what really matters is what you do with it. So I want to leave you with something simple. A few commitments you can carry with you as you continue your work. Not something you memorize, but something you can come back to. The first is just asking who is not in the room. Before you start a project, pause and think about whose perspectives might be missing and how that might show up later. The second is about testing. Try to get your work in front of people who don't think like you, who don't use technology the same way as you, or don't come from the same background as you. Because that's where you start to see things you would not catch on your own. The third is timing. Take a moment to pause before you launch, and again before things start to scale, because small decisions early on tend to grow with the system. And then the fourth is how you think about this work. Bias auditing is not extra work. It should be part of designing something that actually performs well in the real world. And the fifth is about your role on a team. If you notice that something is being designed from a very narrow perspective, say something. Speak up. Those moments are very important more than they seem to be. And just to make this practical, there are 3 small things that you can really try this week. First is keep the framework close. So use the pause steps on whatever you're working on next, even if it's a class project or, in this hackathon. Second is look for your blind spots early. Bring in testers who see the world differently from you, and do it before decisions are locked in. And third, make it part of how your team works, whether it's a quick check in a sprint, a question during a review, or something you raise in a demo. Build the habit into the process. Because you don't have to get everything right. What matters really is building the habit of pausing, noticing, asking, and adjusting as you go. Time to debug biases before you launch. That's your moment to pause, because pausing is where better decisions begin. You've seen the framework, you've worked through it, and you have something you can take with you. We have to remember bias is part of how technology takes shape. What matters is choosing to look for it early and often. And that really comes down to the kind of builder you want to be. The ones who pause tend to design systems that hold up better in the real world. And I have a feeling that's why you're here. So, as you keep going, keep designing, keep questioning, and keep pausing.
Before we end, here's one thought to take with you. Every system eventually shapes someone's experience, often in ways that are not obvious at first. What matters is having a way to pause and see those patterns early. And you've done that here. So as you continue your projects here and beyond, Take that habit with you. That's where better outcomes begin. Thank you.